Today, we're diving into one of the most fascinating and personal frontiers in health science, the evolving story of pain. For most of us, pain feels like a simple alarm bell, your body's way of saying, something's wrong, fix it. But what happens when that alarm keeps ringing long after the danger has passed? Chronic pain affects nearly 1 in 5 adults worldwide, turning what should be a temporary signal into a life-altering condition. In this article, we trace the remarkable evolution of pain theory, from ancient mechanical views to today's cutting-edge neuroscience, and explore what this journey means for your own health spectrum. The old view, pain as a simple alarm bell. For centuries, medicine saw pain through a straightforward, mechanical lens. In the 1600s, René Descartes pictured it like a bell ringer. Step on a flame, a thread pulls, and a bell rings in the brain. This specificity theory assumed pain was a direct, proportional response to tissue damage. Find the broken part, repair it, and the pain should stop. It worked reasonably well for obvious injuries like fractures, but it fell apart when doctors faced phantom limb pain in amputees or burning neuropathic pain with no visible damage. Patients were sometimes dismissed as imagining things. The old model had no room for amplification, internal generation of pain, or the brain's active role. It treated the nervous system like a static machine rather than a living, adaptable organism. The system's revolution, from gate control to the neuromatrix. Everything changed in 1965 when Ronald Melzack and Patrick Wall introduced the gate control theory. They showed that the spinal cord isn't just a passive cable, it's a dynamic gate that processes signals. Large nerve fibers, carrying touch, can actually close the gate and reduce pain signals, which is why rubbing an injury often helps. For the first time, science acknowledged that mood, stress, distraction, and even your thoughts could influence pain intensity. Melzack later took it further with the Neuromatrix Theory. Pain, he argued, isn't simply sensed in the body. It's constructed in the brain by a widespread network called the body-self neuromatrix. This network weaves together sensory input, memories, emotions, and expectations. That's why phantom limb pain can feel vividly real even with no limb present. The brain's matrix keeps generating the experience. Today's modern synthesis, nociplastic pain, gliopathy, and pain as a homeostatic emotion. We've now moved into a truly integrated understanding that blends these ideas into a systems biology view. Nociplastic pain, recognized by the International Association for the Study of Pain in 2017, describes what happens when the nervous system itself becomes hypersensitive after prolonged stress or inflammation. The gain on the alarm gets turned up permanently, a state called central sensitization. No ongoing tissue damage is required. The system has simply learned to stay in pain mode. Neuroimmunology and gliopathy reveal that chronic pain is often an immune-driven condition. Glial cells, microglia, and astrocytes, once thought to be mere support cells, become activated and release inflammatory chemicals. This creates a self-sustaining loop of neuroinflammation, essentially turning chronic pain into an inflammatory disease of the nervous system. Leading researchers like A.D. Craig now describe pain not as a pure sensation, like touch, but as a homeostatic emotion, similar to hunger or thirst. It's the brain's urgent signal that something needs attention to restore balance. This explains why pain lights up the same emotional and motivational brain regions involved in survival instincts. These advances show us pain is far more than a peripheral alarm. It's an emergent property of the entire nervous system, plastic, adaptive, and deeply intertwined with our immune health, emotions, and environment. The missing pieces. Why chronic pain remains so challenging. Despite this progress, significant gaps remain. Gaps that matter deeply for anyone living with or supporting someone with chronic pain. We still grapple with the hard problem of subjectivity. We can map brain activity and measure inflammation, but we have no objective thermometer for the private experience of suffering. Diagnosis still relies on self-report, which is valid yet frustrating for both patients and researchers. Animal models have taught us enormously about central sensitization and gliopathy, yet drugs that work beautifully in lab mice often fail in humans, highlighting how human pain is shaped by genetics, lifestyle, gut health, stress, and social factors in ways lab settings can't fully capture. Perhaps the biggest mystery is chronification. Why do some people recover fully from the same injury, while others slide into long-term pain? Emerging clues point to epigenetic changes, molecular memory that can lock the alarm system in the on position, but we still lack reliable ways to predict or interrupt that transition early. Finally, pain is profoundly social and existential. Isolation, trauma, and socioeconomic stress aren't just psychological overlays, they biologically reshape the pain matrix. A truly complete model must integrate these human realities alongside the biology. A new perspective for your health spectrum. Understanding these scientific shifts isn't just intellectual, it's empowering. Chronic pain pushes us rightward on the health spectrum, away from optimal vitality. But knowledge itself can help nudge us left again. When you grasp that pain is constructed in the brain, influenced by inflammation, stress, sleep, nutrition, and purpose, you gain new tools. Better sleep calms glial overactivity. Anti-inflammatory nutrition and movement support nervous system balance. Mindfulness and emotional regulation can literally modulate the gait. And a sense of purpose and community buffers the social dimensions of pain biology. The future of pain care lies in precision approaches, identifying your specific pain phenotype, intervening early with epigenetic and neuroimmune strategies, and treating the whole person, body, mind, and social context. Pain is the price we pay for a nervous system capable of learning and surviving. Our goal isn't to eliminate it entirely. A life without any pain capacity would be dangerous, but to quiet the phantom alarm when it has outlived its usefulness, so millions can reclaim energy, clarity, and joy. What's one insight from today's exploration that resonates with your own health journey? Have you or someone you know experienced chronic pain that science is finally beginning to explain? Share it in the comments below. If this deep dive into pain science helped shift how you think about wellness, please hit like, subscribe, and turn on notifications so you never miss our next evidence-based exploration of health and life.